All right. So at STP we have a temperature, and the temperature is what? What's standard temperature? That's right, 273.15 Kelvin, okay? And what's the pressure? Hmm? Okay. And we want to find density. Well, density is both, what is density made up of? Mass and volume. So what we want to do is to find an answer that has both mass, density is mass over volume, right? Okay. Let's see. If we knew the molar mass of CO2, we could find its number of moles, couldn't we? Yes? Let's do that. On your periodic table it's 12.01 and oxygen is 16.00. One of these and two of these. And that's grams of CO2 equals 1 mole of CO2. Okay? So, we've got mass and volume, you've got pressure and temperature. We're getting close to having PV equals nRT, aren't we? Okay, we've got pressure, we've got temperature. If we just pick a mole of this stuff, okay, we can have this mass. And so, let's see, if we have a mole of it, we can just take, say, 1 mole here. We could calculate the volume of 1 mole, couldn't we? Okay. If we have a volume of 1 mole, then we could take and calculate the volume. Then we can put the mass we have over that volume and we'll have density, correct? Does that make sense? You with me? Okay. That's all we got to do. All right, so if we're going to say that they're going to have, we're going to start with, just choose to take 1 mole. Okay, so N is going to be 1 mole. All right, which we know is equal to 44.01. We want to find the volume of 1 mole. Can you do that? Can you plug all those values in using your test reference? Okay, so pressure we say is 1 atmosphere. Work it with me now. Work ahead of me. Don't expect me to do it. Don't be passive. V we don't know. 1 mole is what we're going to say this is. R is 0.082. What is it? 821 is what you have? Okay, I've always used 8206. No, it's probably 821 on yours. I was just looking for it. 821 is what you have. 0.0821 liters times atmospheres over Kelvin times moles. Okay? And then temperature we said is 273.15. So we're trying to find volume. So I can just take and put this over 1, and multiply by the reciprocal of 1, right? 1 over 1 atmosphere. That all cancels over here, but I do it the same thing to this side. You understand what I'm doing? I'm isolating the unknown. So I'm getting volume. This is going to be the volume of 1 mole, right? Yes? Okay. See, we get to cancel moles now. This is, I forgot to put my unit of measurement here. This is Kelvin here. Cancel Kelvin. cancel atmospheres, and we've got liters, and that's how we measure, one way we measure volume anyway. So, plug in your calculator. Plug it in, plug it in. What do you get? 22.4 after you round it off. Okay, so that's liters of CO2 for 1 mole of CO2, which happens to be equal to 44.01 grams of CO2. Well, now we have everything we need to calculate the density, don't we? Mass over volume. So the density then is going to be 44.01 grams over 22.4 liters. Now most of the time in chemistry when we calculate density we do it in grams per milliliter, but there's nothing that says we have to do it in grams per milliliter. Most gases are actually calculated in grams per liter. Okay? I got 1.96 after I round off. Is that right? Yeah, I mean, we only need 3 digits. We've got 22.4 here. So the density of CO2 is 1.96 grams per liter. Sure, but you don't. Now you're talking about the density derivative of the ideal gas law? Yeah, that's fine if you want to memorize that equation. But that equation is not in your test reference. Okay? But there is a density derivative. And here's what she's showing. She's saying that density is equal to the molar weight, which is the same thing as the molar mass, times pressure over R times T. So you can calculate density directly that way. All right? And so what we do for that is we take that molar weight here, okay, which we write as a fraction. We write the molar weight as 44.01 grams per mole. That's the molar weight times the pressure, which is 1 atmosphere, over 1. We're going to put all of that over the R value, which is 0.0821, right? Liters times atmospheres over Kelvin times moles times the temperature, 273.15 K. All right, now that's a complex fraction. Yes, but you know what? It's called complex for a reason, because it's a fraction over a fraction. Now, correct me if I'm wrong, but don't they call that a complex fraction in math? You don't remember? Yeah. Okay, you've heard that before? Maybe they don't teach that in math classes anymore. I remember hearing that in math classes. All right. What I was taught when I was in school was a little thing that kind of reminds me what to do when I have a complex fraction. Okay? Ours is not to question why, only to invert and multiply. You don't remember that? That's a famous. That's a play on a famous quote from a famous poem, "The Charge of the Light Brigade." Ours is not to question why, only to do or die. Huh? Well, you should know it then, right? Okay. So, to solve a complex fraction, you invert and multiply. Well, that means you take the bottom and flip them and multiply by the top. So density is equal to 44.01 grams per mole times 1.00 atmospheres over 1 times, we're going to flip this now, Kelvin times moles over 0.0821 liters times atmospheres. So Cassoni, is this what you did? I'm going to flip this. Okay, well, the only way you can cancel your units properly, well, I don't know. Unless you do this a lot, you might not realize that how to cancel it correctly. I've had a lot of students mess up badly trying to cancel units just from this complex fraction because they don't know how to do it properly. Okay, but if you do it like this, then canceling units of measurement makes sense. Kelvin cancels Kelvin, moles cancels moles, atmospheres cancels atmospheres, and let's see, oh, we got grams over liters. Ta-da! Isn't that density? Okay, is anybody doing the math yet? Huh? Prove it. Show me, I'm from Missouri. No, I'm not from Missouri. I'm not from Missouri. Don't know that I've ever been to Missouri. Huh?
What are you talking about?
Y'all need to look up the slogan for the state of Missouri.
God.
What?
Just thank God.
Not the last time I checked.
I'm from Missouri. Prove it. I'm from Missouri. I'm not from Missouri.
You know what? It sounds silly, but you sound silly as somebody who knows what the slogan for Missouri is.
I don't think that's anyone here.
Well, so look it up.
I don't think anybody should look it up either.
Okay, it's fine. Then you can be ignorant. What?
I don't have signal.
Anybody got the answer yet?
Yeah, it's 1.9624879.
So it rounds off to 1.96 grams per liter, right?
Yep.
Same thing. So either one's fine. The PV equals nRT is what you have in your test references for an honors chemistry. The other, what I call the density derivative of the ideal gas law. It's the same thing. It's just written in a different way. Gives you the same answer. Okay? We just write it with different. We just figure out what density would be using the ideal gas law, and we plug it into that. So I like that, but you don't have to use that to get there. You can get there other ways. As my mama used to say, there's more than one way to skin a cat. Yes, she did at one time, but she's not talking about mammals. A lot of people who hear that phrase don't know you're not talking about mammals when you say that. Yes, that's correct. That's how you used to prepare catfish